Hey, welcome to my question show. Your questions, my answers. As always, wherever you are across my channel. If a question pops in your brain, just write it down. I'll gather them up and I'll answer them here. All right, let's get into this week's questions. Ryan Schmitz, you saw the footage released today of Perseverance rover landing. What things about it impressed you the most? Apart from everything, so that's the baseline is everything impressed me. But part of it that's kind of amazing, the big advancement with Perseverance in terms of entry, descent, and landing, it's a bigger parachute. It's the heaviest payload that's ever been landed safely on the surface of Mars. It had an artificial intelligence system, a machine learning system that was used to find the landing spot. And so while previous missions, they had to really program in what the landing spot was going to be, Perseverance had a big landing area. And as it was getting closer and closer, it knew all of the locations, all the rocks, all the boulders, everything. But as it got closer and closer and closer, it fine-tuned its trajectory and chose its landing spot. Because of course, it takes 10 minutes to communicate with Mars. And so it found its perfect landing spot. And I love that. In terms of the actual video, of course, you're seeing the surface of Mars, but it's always so hard to know the distance because craters can be craters. They can be big, they can be small. You never really know how far away they are. But as you get closer and closer and closer, and they tell you the distances, and then you get that wind, the exhaust, the rocket exhaust blowing away on the surface of Mars and moving it around. Yeah, that's just incredible. And then watching the sky crane drop the rover down gently on the surface. The first couple of pictures that we got back were pretty disappointing, but I know they were just trying to hustle them out the door, but NASA just followed up with just a devastating response to people who are like, oh, those are the best pictures. Oh man, that's so good. And there's been so many more too already. Like the torrent is open now. And of course, like Curiosity, Spirit, Opportunity, Juno, Cassini, New Horizons, all of the various missions, the data is just getting disgorged onto the internet in vast quantities. So if you want to pour through the pictures and find all kinds of things in there, get your pareidolia, go mad, you can. But yeah, and the best is yet to come. We got word that the helicopter has come online and is ready to fly when needed. It's amazing. And just to think that like Perseverance is a Curiosity class. It is a nuclear battery powered rover with a ton of instruments to help find life, past and present life on the surface of Mars. It's a good time. I'm really looking forward. I mean, we're already full court press on Universe today. I think we had many articles about it. We've got many more in the pipeline now. Speculative stuff, sort of behind the scenes stuff. So it's going to be great. Visto2D asks, how is such good data links Mars to Earth achieved? So this was not live. People always ask, like, why don't we have like a live data feed? Why does anybody include a live video on one of the NASA rovers? That would shut the flat earthers up, which of course nothing will shut the flat earthers up. But it's like video in terms of like its value for scientists is pretty low. Photographs are what they want. Black and white photographs are their favorite because that gives you the most data. If you have to produce a color photograph, then by all means, take a black and white picture with a green filter, take a black and white picture with a red filter, and then a blue filter, and then combine them together and you got a color photo. But really, all science instruments are pretty much usually black and white. And they take pictures because a photograph at the high resolution gives you the kind of data that you need to be able to analyze and understand what it is that you're looking at. And then, of course, like, what is a video? Video is just a bunch of pictures, right? 24 frames per second, 30 frames per second, 60 frames per second. Like, it doesn't really matter. And so in this case, the data sort of connection between Earth and Mars is medium strong. It all really depends on the size of the receiver here on Earth. NASA's got its 90-meter radio telescopes that they can, the Deep Space Network, that they can point at different targets across the solar system, from the Voyagers to New Horizons and now to Perseverance, and to be able to receive that data. And so Perseverance, and I forget the number, it's equipped with like 24 cameras. When you add all of the ones that were on the Sky Crane and the Aeroshell and and then of course like hazard cams and all the various microscopes and stuff. And so it's going to be taking pictures nonstop with all of these cameras and sending them this mountains and mountains of data back to Earth as quickly as it can. And so obviously someone stitched together all of the pictures that were taken into what looks like video. And it was beautiful. It was amazing. And I can't wait. There's a microphone on this thing. We're going to hear what Mars sounds like. Oh, it's so good. Arjun asks, how do they test the AI for something like this so it comes up with valid solutions? Do they put cameras on other missions? Well, the term, I guess, is machine learning as opposed to necessarily artificial intelligence. But I mean, they just practice. There's a sandbox in the backyard of NASA JPL where they test out their rovers, and they develop software, they install them on rovers. Sometimes they install it on the actual rover. They have, a copy of Perseverance or a copy of Curiosity. And other times they just install it on some other system, and then they turn it loose and see if it can understand what it's looking at and designate targets and designate locations. And Perseverance has a ton of this built on board. I mean, we are 8 years after the landing of Curiosity. So 8 more years of better technology. 9 years? Almost 9 years. 2012 to 2021. So yeah, 9 years. And there's just been a giant strides in machine learning and artificial intelligence in that time. And miniaturization of computers and better software and better techniques, better camera systems, lighter computers. So when you really think about what's going on inside, although the chassis is similar, Perseverance is a vast upgrade over Curiosity. Tons and tons of new technology that's going on inside that rover. And yeah, they run their experiments. I mean, there's a ton of these. There's the ones that NASA is doing at JPL, but also the European Space Agency is testing rovers in the Atacama Desert. You're seeing these rover tests. Even in Canada, we're testing out various rover concepts. You're seeing this all around the world. And you test and test and test your software, and then you apply it to the actual rover. And Perseverance will be getting upgrades while it's at work on Mars, which has got to be really scary. Can you imagine being like a software engineer and you have to reboot your rover? And of course, if anything goes wrong, you can't just go over and turn it off and turn it back on again. Oh, yeah. Like just imagine a computer problem that you can't fix by turning it off and turning it back on again. No matter what, it has to work properly. Anyway, Jake Tepper, how do they decelerate at 20 meters? Look like rocket stages. For those who don't know, right, there's this idea of the 7 minutes of terror, that the spacecraft has to come through the atmosphere of Mars. It's whole entry, descent, and landing. So the first stage is that it's got this aeroshell. It's coming in like a bullet, and then it uses this aeroshell, and it actually can use this to maneuver itself a little bit and maintain it. Slows down a bit, and then when it hits the right speed, it kicks away the aeroshell and deploys the parachute, which we saw in that original video. And then the parachute deploys, that slows it down, and then as it's approaching the surface, the problem is that the parachute just won't work. The atmosphere on Mars is too thin to let a parachute drop the rover gently on the surface. So you still need some kind of rocket. So what it has is, instead of the rover just sort of landing, I don't know, like a SpaceX Falcon 9, it gets deployed under this thing called the Sky Crane. And then the Sky Crane hangs down, and then it has rockets that are firing off of it. And then it sort of reels the rover down to the surface. And so it's hovering. And so those rockets that you were seeing were actually rockets that are blasting off the Sky Crane in multiple directions to keep it stable. And then it just reels down the rover and lands it gently on the surface of Mars. Just such a clever solution. I really love it. Pacer asks, is there a microphone on it? And if so, what will we hear? I mentioned this briefly, but yeah, there's a microphone on Perseverance. For the first time, there is going to be a microphone, a proper microphone on the surface of Mars. And what will we hear? Mars. We're going to hear the wind blowing past the rover. We're going to hear the sand scraping under its wheels as it's trudging along. We're going to hear its instruments. We're going to hear echoes as it's going through canyons. We're going to hear the helicopter take off nearby and crash. We're going to hear all those things. And we're going to hear them differently. We're going to hear them in the Martian atmosphere, in the thin carbon dioxide atmosphere. And to be honest, I don't know what it's going to sound like. But we'll play it. We'll hear it together when we actually do hear it. I mean, different atmospheres. The atmosphere of Venus would make things sound different from the atmosphere of Mars, from the atmosphere of Titan. The atmosphere has a big impact on what sounds sound like. Water is different than air. Yeah, I mean, people have been attempting to get a microphone onto the surface of Mars for so long, and either the microphones were removed for cost restriction reasons, or they were or the spacecraft carrying the microphone crashed into Mars, because Mars eats spacecraft for breakfast. And so this is it. This is the time that we get we'll hear the scamper of Martian life. Yeah, I can't wait. I would like just, this is it. This is the chance. This is the thing. Am I excited? Can you tell? So stoked on this. All right. Arjun. When is the ESA rover going to clean up after Percy? Like, as you probably know, Perseverance's job is to search for past evidence of life on Mars. And so it's going to be, it's got microscopes and it's got chemical X-ray chromatograph, and it's got a little oven inside, and it's going to be sampling and tasting and drilling and shooting lasers and really trying to understand the surface of Mars. But that's like half its job. The other half of its job is to poop out samples onto the surface of Mars as it goes along. And so you can imagine it's gonna find some really interesting rock formation, something that really kind of screams bacterial mat, and then it's going to scoop up a sample. It's gonna, taste it for a little bit, and then it's gonna plop it out on the surface of Mars and then keep driving and tag the location. And the plan is that the European Space Agency is building a fast rover that's going to follow in the footsteps of Perseverance, scooping up all these samples, and then it's going to deliver it to a NASA-built return rocket that's going to launch all of those samples into space. And then a European return spacecraft is going to catch those samples and bring them all back to Earth. And so when we think about, say, the Japanese, they got like 5 grams with Hayabusa 2 of asteroid Ryugu. You've got just a few particles from stardust. Who knows how much we're going to get coming back from OSIRIS-REx. But you're going to get probably dozens. I think when I remember originally, the Chase rover the plan was it was to have room for something like 36 samples or something like that. So you're going to have all these little samples of all these different spots, all returned to scientists on Earth so that they can examine them really well to figure out. And I mean, apart from the solar system delivering us samples of Mars in the form of asteroids, we've never gotten a sample from the surface of Mars. It seems weird that we haven't done this yet, but we haven't. That we don't have a rock. We have rocks from the moon, but we don't have a rock from Mars that we picked up, that wasn't sort of thrown at us by an asteroid. And so yeah, the Mars sample return mission is the next big step. So now we've got the samples being gathered, and both Perseverance and the European Space Agency's rover is going to do the same thing. They're both going to be gathering up samples, and then they're going to be returned home. And so we are within, I don't know, a decade or so, going to actually have in our hands all of these samples from Mars, which is great. And that'll be the clincher. I mean, up until this point, Perseverance is going to find all of these interesting samples. Like, unless it sees a skeleton or some animal scampering about on the surface of Mars, it's going to be very inconclusive. But when these samples actually come home, then we're going to know for sure whether or not these are life, because life can't hide anymore. Hal McKinney. Do any Mars missions point their scopes back at the stars or Earth or the sun? Yeah, Yeah, the most of the time, the Mars missions are, of course, pointing down at Mars. The Mars Reconnaissance Orbiter is looking down at the surface of Mars. Occasionally, it looks over at Phobos and Deimos, but it has looked at the Earth. And the rovers have, again, mostly they're looking down at the surface, but every now and then we've got a couple of pictures of Earth in the sky. Like we see Mars or Jupiter in the sky, the rovers see Earth as a bright star in the sky. And there's definitely pictures of that. Colin, do you think that we can use the Starshot method to get to Mars quickly, using lasers on Earth or the moon and use a solar sail to fly to Mars? Sure, in theory, the Starshot system will work anywhere. You take a big, powerful laser and you take a tiny little spacecraft and you fire your laser at the spacecraft, the solar sail on the spacecraft, and you accelerate it to some significant fraction of the speed of light and you send it on its way. What's the flaw? What's the problem? The spacecraft flies to Mars at 10% the speed of light and goes right on past. There's no way to slow it down. So yeah, you could send these little missions to Mars. You could, and they would be whatever, a couple of hours later, they would fly past Mars and then they'd be gone. So it's not really great from a science point of view if you're like trying to stick around and learn about the place that you've gone to. But I can imagine slower versions. I mean, you don't have to go 10% the speed of light. Like you can go anywhere in between. You can go as fast as a rocket. You can go as fast as you need to go. But if you want to stay, then you got to have a way of slowing down. And the only way to have a way of slowing down is to do the opposite, because your little solar sail doesn't have a rocket, any kind of propellant on board. You got to have a way to slow it down. And so I can imagine this future where there's a laser powered network across the solar system, and they are zapping spacecraft with these lasers and they're accelerating them, and then they're zapping them again at the receiving end to decelerate them again to get there. But it's it's an infrastructure. So imagine it's the equivalent, the solar system equivalent of like a highway system. Like we just don't have that yet. And so until we have that, we need the kind of vehicles that can slow themselves down when they arrive at their destination. So, but I think Starshot is like, I don't think we'll see Starshot sent to other star systems in our lifetime. Like, I just don't. But I totally see that technology being adopted and used for inside the solar system. Like, what a great way. You could go and visit 1,000 asteroids simultaneously, Kuiper Belt objects, Oort cloud objects. You can just go wherever you want in the solar system quickly, learn. That's where I think that Starshot is going to be really strong. Pray for Mojo. I was just pondering this. Does the space station move faster after it gains mass from a supply mission or more astronauts? All right, so let's do a thought experiment together, all right? If you drop a hammer or let's say a 1-pound hammer or a 10-pound hammer, which one drops faster? The answer, of course, is they drop at the same speed. This was the experiment that Galileo did, where he stood at the top of the Leaning Tower of Pisa and dropped two objects and found that they dropped at roughly the same speed. And obviously, if you drop a feather, but they did the experiment on the moon and they dropped at exactly the same speed. So the velocity that you require to continue falling around the Earth is not dependent on your mass. It's dependent on the mass of the thing that you're orbiting. And so in this case, the space station is orbiting around the Earth. And so, no, the moon, the space station, whatever it is that's orbiting the Earth, it doesn't matter what mass they are. What matters is the mass of the Earth. Now, obviously, in the case of the moon, at a certain point, the moon and the Earth are orbiting around a common spot, but yeah, so no, they doesn't have to change, doesn't change their velocity, doesn't change their orbital velocity, their mechanics in any way. And it's, it's just kind of cool to just kind of go back to that original idea. I'm sure if I asked you that question, what drops faster, right? Two objects of different weight, you would know. And then you could sort of extrapolate that to the space station. Dr. Samimi, I wonder how actively we observe the possibility of asteroid collision with the moon. What if this happens? We see asteroids collide with the moon all the time. In fact, we were doing a live stream of a total lunar eclipse, And although nobody noticed it while it was actually happening, when we went back through the footage, there was a little flash in our footage of the moon that was a meteorite crashing into the moon. Not big, maybe, I don't know, like half a meter across, right? But yeah, a big space rock, an asteroid crashed into the moon while we were watching. So this happens all the time. And in fact, at this point, amateurs and professionals find these on a regular basis. In fact, although it's not the moon, we just have word that an asteroid crashed into Jupiter, and it was seen by Juno. So, and amateurs have seen asteroids crash into Jupiter, and of course there was Shoemaker-Levy 9, which was like a comet that crashed into Jupiter. So we have witnessed objects crashing into both the moon and other planets, and it's happened in the past, and it's going to happen in the future. I mean, are you worried if like a really big asteroid crashes into the moon? Even that wouldn't be that big of a problem. Like if a really big asteroid crashed into the moon, it would throw out some debris. The debris would probably burn up in the Earth's atmosphere if it even got to us. So I wouldn't be that worried about an asteroid crashing into the moon. An asteroid crashing into the Earth, that's the problem. So don't worry about the moon. Worry about the planet that we're on, because that's where you live. FD Skate. You mentioned Babylon 5 in an earlier episode. It would be cool to hear your take on the series with one long story spanning over 5 seasons. Have you watched it and did you enjoy it? We have begun watching Babylon 5 remastered. So we are 8 episodes into season 1 at this point, Carla and I, and it's good. It's like, I remember the first season being weak. The first commander being kind of meh. The stories being very Star Trek-esque and not being super great. But I was wrong. It's really solid. The makeup is terrific. Like, the aliens are better than anything Star Trek ever did. And this is like season 1. This is like they're getting their first tentative steps in figuring this out. And it is already so much better than what I remembered. And obviously, upscaling all of the computer graphics on the show made a huge difference. But yeah, and the stories are good. You know, like they're dealing with political intrigue. They're dealing with like issues of colonialization and interactions between the races. And yeah, and I remember season 1 being the weak one, so I can't wait to get into the other seasons when the story really kicks in on season 2 with Sheridan and goes all the way through to season 5 and the movies. Yeah, I'm all in. I'm on 100% on board. So yeah, if you haven't already, definitely watch Babylon 5. It's not as good as The Expanse, but it's really good. Pacer, are you only doing 1 live stream per week, or is more content planned? So I talked about this a bit in the past, but I'll sort of bring you up to speed on where my current thinking is right now. So right now I do 1 live stream on Mondays, which turns into the question show now. And then I'm trying to do 1 interview per week. And that's just done live, and we don't do any follow-on editing. And then all that sort of goes out into the podcast. I've sometimes had no interviews in a week. Sometimes I've had 2 interviews in a week. I leave the interview time up to the guest. They get to choose when we do the interview. And so sometimes I get interviews early in the morning, and sometimes it's late at night, and it's all, and I know that's kind of frustrating, but that gives us access to more guests than trying to stick to a live schedule. So I try to stick to the live schedule with this show, and then I follow up with the interviews. And so right now we're getting pretty dependably 2 things a week. Then of course there's the weekly Space Hangout, which if you aren't aware of that, it's a whole other show that we do on Wednesdays, and we have a big round of space news, and we have another guest over there. And then of course there's Astronomy Cast, which we do on Fridays, which is me interviewing or having a nice conversation with Dr. Pamela Gay, and then we answer tons of questions there. So that's like 4 things. And then we also do the virtual star parties. The big piece that's missing in the schedule right now, or in the sort of the way things used to be, is the guide to space episodes. And that's where I would take some big topic and I would break it down and do a voiceover, and we'd have lots of cool graphics, and I would write a big script. And I mentioned this a couple of weeks ago that I'm feeling unhappy with the quality of them. And after I said that, a lot of people were like, "No, Fraser, they're great. You're the best." I'm like, "Oh, you." But I really like interviewing the sources directly. I think that's the key. That has to be the bedrock of what I do. That me sort of trying to summarize the interesting science in a way that tells a compelling story and is scientifically accurate and pushes the cutting edge of what we're talking about requires going to the source. And so the format that I want to go to, and I'm still kind of working out, and this is, so we're, it's sort of like we're back to basics. We're Tiger Wood redoing the golf swing, which is a terrible analogy. We've gone back to basics on how we do the question shows, to do them live and to then also integrate other stuff around. And then we're also going to be sort of dismantling the way the Guide to Space is done so that it'll feel a lot more like me being the host and then cutting to different interviews to assemble a story, but the story is being told partly by me and partly by the actual researchers who are doing the work, and then interspersed with video and stuff like that. And so I think that's where this has to go, that there's only so far that I can be the summarizer in chief, where I have to then move to having it be more of a journalistic approach where I'm interviewing people who are doing the actual work. And so that's the plan. But it's hard and it's complicated and it's going to require a lot of just flailing around in public. And so the bedrock of that has to be the interviews. And so we've we've been great. We've had like an interview a week almost. And that is sort of testing out that piece of it, to sort of have a really interesting person who's working on the cutting edge of something that I don't really know a lot about, and bring them on and ask them a bunch of questions and really understanding what they're working on, and also giving you a chance to understand what they're working on. And then the final piece of the puzzle is to then take all that stuff and turn it back into a story that summarizes and pulls it together. So I understand that you want me to be the guy that I was, but I feel like I'm not doing it justice. And I think that it needs to be more. And so that's what's driving the sort of the next stage of this evolution. And I apologize if that's what you loved, was me talking about nuclear rockets or whatever for a while. That's just kind of where my brain is at right now. And I hope, for some people it's not going to be the thing. And for other people, it's going to be exactly what they want. And so, but I think, you see like a person like Joe Rogan interviewing people seem to like that. So I think there's some appetite for really interesting interviews. We'll see where it goes. More questions in a second, but first I'd like to thank Wiki Anderson, Matthias Roberto, Charles Gibbs, Sean DeSenza, Craig Ewing, Fuddle Clutch, and the rest of our 855 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universe today. Horizon Brave. Fraser, do you think there'll be any plans to send probes to distant nebulae in the future? I'm not sure you know how far away nebulae are. So the solar system is, let's say, the one astronomical unit, right? That's the distance from the Earth to the sun. And we measure large distances in the solar system based on astronomical units. Out into the Kuiper Belt, you're about 100 astronomical units, 100 times the distance from the Earth to the sun. If you want to go out into the Oort cloud, you're in the 20,000 to 50,000 astronomical units. You're about 2 light years away to get out into the outer reaches of the solar system. And of course, Alpha Centauri, say, is 4.5 light years away, so maybe that's 400,000 astronomical units. I'm sort of doing the math in my head here. 50,000, 100,000? Yeah, more than 100,000 astronomical units to get to Alpha Centauri. And that's like 4 light years away. And now we switch to light years. The nearest nebulae are in the dozens, if not hundreds of light years away. And so, like, we won't get to Alpha Centauri in centuries. We're not going to be able to get to a nebulae in centuries. Of course, nebula, there's different kinds. There's the star-forming nebula, like the Orion Nebula. There's planetary nebula, like the Ring Nebula. But the thing that's kind of interesting, that's kind of like, we see these beautiful pictures of like the pillars of creation, Eagle Nebula, and you think, oh, like, wouldn't it be amazing to hop in my spacecraft and to fly to the Orion Nebula and just like look out the window, and it would be just like Babylon 5, just like Star Trek, like just be like looking at a space aurora, but it wouldn't. When you look at a picture of space, of the Orion Nebula, of any of that stuff, you're looking at a picture that was made on a camera with a very long exposure. In some cases, minutes, some cases hours, days, weeks of photons falling onto the camera to build up this image, photon by photon. Your eyes are flushing the photons every few seconds, right? Our meat cameras have an exposure, a maximum exposure of just a couple of seconds at the most. And so even if you could stand right on the edge of the Orion Nebula, you wouldn't see anything. It would look just like maybe it's a little fuzzy in the sky, maybe. And there's a bigger problem, or another problem. Not necessarily a bigger problem. Like, our crappy meat camera eyes are a big problem. But the other big problem is that if you actually looked at, as you get closer to an object, the brightness of that object gets spread out over a larger and larger area. And I'll give you an example. We are inside the Milky Way. I know you would love to see Andromeda. Wouldn't it be cool to be over top of Andromeda and be at the right distance? You just see this incredible swirling whirlpool galaxy. You wouldn't. We're in the Milky Way. We couldn't be any closer. And yet you have to be in incredibly dark skies. And when you go out with your own eyes, you see a fuzzy patch in the sky. And that's like the galaxy that you're in the middle of. And so as you get closer to some object, like say the Orion Nebula, the size of it spreads out in your field of view, and the brightness spreads out as well. And so you could never get close enough to be able to actually see it well. Sina Farhat, when will we see your outdoor green screen again? That's a good question. All right, so I'll talk some gear here for 1 second here. So I bought a new camera, which is that I bought the Sony A7C camera. And so I was using the Panasonic Lumix GH5, which is a phenomenal camera, 4K, 60 frames a second, but I just can't trust it. The autofocus on it is so bad. And so I would go and set up outside and look at the footage, and it wasn't behaving properly. I'd throw it out. So the plan, and it's really hard to connect a GH5 to a computer and to be able to use it as a webcam. So the plan is that this is going to be my webcam. And next week, you will see me. Let's see, does this work? Yeah, you'll see me. There we go, in this camera. Look at this. Look at that. You can see. Let's see if it finds my eye. There. Boom. Eyes found. Look at that. It knows where my eyes are. It won't be shifting focus. It is locked. Oh, found the other eye. Perfect. Yeah. So I was having a lot of technology fail, and this is much easier. It's also wintertime and wet on the West Coast. So we'll get back to the green screen. We'll get back to that. But also, the problem is that a lot of the stuff that I do now is very much interactive with the computer and talking to people. And so it's kind of hard to do that outside. But if we kind of get to that future where where it's sort of partly me talking, partly splicing in pictures, that kind of thing, yeah, we'll go back to being outside. I live in such a beautiful part of the world that it's hard to let that go. But I understand that was like my thing. Right? I stand outside, no matter what the weather is. Yeah. Mitch Harpino, I sort of know your stance on the Fermi paradox, but what are your thoughts on what Bob Lazar has said? I have no opinion on what Bob Lazar has said. He thinks that aliens have visited the Earth. Show me. Like, just let me see the spacecraft. Let me see the rocket. Like, until then, I will withhold my belief. You can't give me belief. I reserve my belief. It's for me. And so, yeah, any claim, aliens are visiting, just like, prove it. Like let me, like, let's go in the spacecraft. Let's take it for a spin. Let's fly to another world. Let me meet the aliens. Like, if I told you that there is milk in my refrigerator, you'd be like, come on, no way, prove it. I'm like, okay. And I open up my fridge and there's milk. And you're like, okay, I'm convinced. There, that was me proving a thing. And so if the thing is hard to prove, then I get to reserve my belief. I get to withhold my belief. And so, yeah, lots of people make lots of claims. And they have insufficient evidence to make me believe in those claims. I don't believe in blips on cameras. I don't believe in interesting stories told by people who are experts. I require more. And so I don't know what Bob Lazar said, but I need proof. I need something physical. I need something that can be repeatable. I need other people to look at that thing. I need it to be something that is better. Good evidence. Not, I know of a thing. I heard a story. A guy who knows a guy saw a thing. So there you go. That's what I need. Gwym, how far do you think we are from the limits of technology? I don't know. I don't think we're very far from the limits of technology. I think the limits of technology, I mean, people have always been predicting the end of technology, the end of science, that technology can't keep going on forever. But I think that there's a long, long way that we can still go. I mean, we are seeing the acceleration of computers, of artificial intelligence, of miniaturization, circuitry. There have been a lot of areas which have legitimately seemed to have stalled. Transportation, the kinds of things that we saw back in the Industrial Revolution. Like, I know that for a lot of people, it just sort of feels like technological advancement has sort of stalled. But when you think of like, what is the gap between us and just like think about like just the human body, right? Evolution over billions of years figured out how to make life, and then figured out how to make animals, and then figured out how to make mammals, and then figured out how to make intelligent mammals, and human beings. And it just by flailing around with with evolutionary pressure, but it was able to come up with an incredibly complicated, very interesting solution to a problem. And so we don't know how it works. We don't know how we couldn't make a human being. Okay, we kind of know how to make human beings, but with our technology, the hard way. And so I think that when you think about just like the basic laws of physics, there's so much that we just don't understand, and we don't know what we don't know. And so there are some interesting places where we do know what we don't know. It's going to make any sense. But there's a video that I recorded with Dr. Paul Sutter, and we were talking about the cosmic microwave background radiation, and that there is a limit to the amount of data that can be actually extracted out of something like cosmic microwave background. That you get to a certain point, and you've essentially reached the resolution of reality. And when you reach the resolution of reality, no new information can be gained. No new advances can be made. But there's lots and lots and lots of places where we're just scratching the surface in what we can know and what we can build. So just imagine I'm sure there are theoretical limits. Like, if you took all the matter in the entire solar system and you turned it into one big computer, and it was running some kind of simulation or science experiment or trying to understand the laws of physics, like at a certain point, you're going to run out of the ability for computers to be able to communicate with each other in a rapid enough speed. Heat is going to become a problem. Like, that's when you reach the limits of technology. But until then, there will still be benefits. There will still be technological advances to be made. And so when you think of like, what are the limits of the technological advances that we've made as human beings, as intelligent mammals scratching around on the surface of planet Earth, compared to all the matter in the solar system turned into one artificial intelligence, its only job is to figure out new technology, it feels like there's a lot more blue sky ahead. Francisco Cosentino, what's the point of sterilizing a spaceship? I mean, I would like our bacteria in other places in case Earth goes extinct. Right, so what is the purpose of sterilizing our spacecraft? Why do we go to this effort of doing planetary protection? And so the problem is, imagine you're trying to figure out if life ever existed on Mars. And I think we can agree that if you could have an answer to that question, did life ever exist on Mars? It would be a fundamental discovery, because it would tell us that life had formed on Mars. And if you could figure out, does it have DNA, or does it use something different than DNA? Like, did life come up with a way of reproducing that is utterly different than DNA? Wouldn't that be interesting? What if it is encoded in the opposite direction than Earth-based life, which is all, DNA is all coiled in the same direction? What if it is related? What if we can find a common ancestor of that Mars life, and we can say, oh, what's interesting is that the life on Mars reached Mars 1 billion years before life started on Earth. So actually life on Earth formed on Mars. Wouldn't that be interesting to know? All of that would be absolutely fascinating. Very important questions that we can answer. But if we cover our spacecraft in filthy Earth bacteria and we land on Mars, then maybe our Earth bacteria can get a toehold into the regions on Mars and take over. And then you dig down on the Martian environment into the regolith and you find some life. You're like, what? There's cyanobacteria. And it came from Earth. Oh no, we brought it with us. And then you keep looking around, and everywhere you look, it's just cyanobacteria from Earth. And so the answer to the question, is there life on Mars? Was there ever life on Mars? Is obscured by mats of blue-green algae everywhere you look. Just no. So the reason why you want to try to keep, the one reason, for the starters, is that you want to try to maintain the sort of the pristine science as best you can. That if you say, I found life on Mars, that you know that you actually found life on Mars, that you didn't just find more Earth-based bacteria. But then I think a deeper philosophical question is it our right to replace ecosystems on other worlds with Earth life? Because it's kind of inevitable. Like, we're going to do it. There's no way it's going to stop us. Like, if there was like a really thriving, interesting ecosystem on Mars that was completely alien from Earth, wouldn't the ethical thing to do to just to leave it alone, study it from afar, try not to mess it up the way, we see what happens on Earth while we mess up ecosystems. So wouldn't it be the ethical thing to not mess it up? I think you can make a pretty good case that if you do find a lot of life, a lot of interesting life on Mars, that you leave Mars as a wilderness to try and let that life keep going so that you can continue to study it and understand it. If Mars is dead, totally dead, it's just a rock, or if asteroids are dead, the moon is dead, Venus is dead, Titan is dead, if it's all dead, there's no life anywhere, then go crazy. Fill it with life. Who cares, right? You're not going to be impacting any existing life forms. You're not going to be answering any questions about where life came from. It's just a rock, and it doesn't matter, in my opinion. But I think that there's a case to be made that there are places in the solar system that are beautiful, that we're going to wish we hadn't ruined later on down the road. I mean, if you take the compounding interest of human, just like, if you take our economy and just continue scaling it up, then we will be essentially acquiring all the resources in the solar system within like 1,000 years. Like, it won't take us long for us to have essentially used up every space in the entire space. And so I think there's something to be said for setting aside large chunks of the interesting solar system as like a nature preserve, as wilderness that can be enjoyed forever, in the same way that we enjoy forests, the way that we enjoy parks, Antarctica, places that are left as wilderness. And even if you went and turned all of Mars, chunks of the moon, Titan, big places in the solar system, and said these are all just wilderness, that would still just be a tiny fraction of all of the space that's out there. And of course, in 4.5-5 billion years, the sun is going to expand and just roast it all and wipe out any life that's in the solar system at all. And so really, you've got to sort of consider the ethical implications with that larger thing hanging over top of you, which is that it's all just temporary anyway, and that eventually the sun's just gonna destroy everything. Have a nice day. If you haven't already, sign up for my newsletter, weekly email newsletter. It's thousands of words. It's written, handcrafted by me. Covers every interesting space news story of the entire week. If you had all space news taken away from you except for one thing, it would be this newsletter. It would serve you perfectly. I think you'll really enjoy it if you haven't already. Go to universetoday.com/newsletter. And of course, everything that I do is available in a handy audio podcast. So you can just get all of the episodes that I do that show up right on your audio device. No problem. And like, I don't know about you, but like, I don't have time to watch YouTube videos. I do have time to listen to podcasts. And so if you want to, as you're like washing the dishes, as you're out gardening, going for interesting walks, you can be listening to mind-expanding space science news. So give that a shot. Just search for Universe Today, iTunes, Spotify, all that. All right. Thank you, everybody. We will see all of you next week.